So how do we work out how many of each element is supposed to be in a formula? Whether we've got ionic or covalent bonding, we're aiming in all cases to get 8 electrons in the outer shell. And that is always the case, except if what we're trying to fill is the first shell, in which case we want only 2 in there. Okay? We call this a stable octet. If we're doing ionic bonding, then the metals lose electrons until they only have 8 left. The non-metals gain them until they get 8. Okay? Because the electrons are negatively charged, that means the metals, when you lose something negative, become positive. Positive ions, we call them cations. And the non-metals become these anions, which are negatively charged. For covalent bonding, we're sharing the electrons, remember, so nothing's getting charged. And we share enough so that everyone gets 8 in the outer shell. And the good thing here is that we get to count them twice. So if it orbits 2 different atoms, we count it for both of them. So to find the number of electrons, we've got to look at the periodic table. When we look at that periodic table, look specifically at the atomic number, which tells us the number of protons. But for a neutral atom, remember that's going to be equal to the number of electrons. Now remember, electrons orbit the nucleus. They're not just randomly arranged, they're arranged into these things called electron shells, and these are our major energy levels. So the first one closest to the nucleus can only hold 2 electrons. So if we have helium, that is a very stable element, and it can hold a maximum of 2 electrons. Once we fill that, the third electron would go into that next energy level. So lithium, if it wanted to get stable, it would have to lose that 1 electron that's on its own in that next shell. It's then going to be left with 2 in that shell, first shell, which we'll be happy with. But shell 2 can hold up to 8 electrons. So when we start getting into our non-metals, instead of losing electrons, what they're going to do is gain them, either by sharing or by getting them from a metal. So nitrogen has got 5 in its outer shell. It needs another 3. It could share that with 3 other things. So 3 hydrogens could each share 1 electron with it. Or it could get them from 3 different metals. Okay? So 3 lithiums could each give up 1 electron to it. Or something like aluminium could give up 3 electrons to it, and then they'd have a 1-to-1 ratio. Ultimately though, what we're aiming for is this stable octet, which is those 8 electrons in the outer shell. So neon, next one of our noble gases after helium, again very stable because it already has that stable octet. So this is the magic, this is what we're aiming for. So if we look at the periodic table, we can work out, just from the position on the periodic table, how many electrons we're going to gain or lose. So if they're in group 1, they're always going to lose 1 electron and be left with a charge of positive 1. Same for group 2. Group 2, lose 2. Ignore group 3 through to 12 for the moment. Group 13 are going to lose 3. Group 14 is a little bit tricky. Depends whether they're a metal or a non-metal. Sometimes they gain, sometimes they lose. So if they gain electrons, they might have a charge of -4. If they lose them, they'd have a charge of +4. And then as we go through 15, 16, 17, they're all gaining electrons. Group 15 have to gain 3, 16 2, and 17 1. Group 18 you'll see has got a charge of 0. They never become charged, they never gain or lose electrons, they all have that stable outer shell to start with.